All right, now let's talk about what happens to the coordinates of the vertices after a rotation. Yesterday we rotated, today we're going to talk about the coordinates as we have been doing. Make this title on the next free page in your math notebook. After that, do all that stuff you do to get ready to concentrate until it's time to write. All right, still talking about transformations, specifically today rotations. This is a 90-degree rotation you see here. We learned to do that yesterday. They look kind of like this. So what we did yesterday is we kind of said, okay, to rotate point A, say it was down 2 over 1 to get to the origin. So we reversed that and went over 2 and up 1 to do a 90-degree rotation. If it was a 180-degree rotation, we just did the same thing. It was like down 2 over 1, so we went down 2 over 1. And then you get the spot for the new A down there. That's what we did yesterday. That was the difficult way to do it. There was also that easy way to do it where you just rotated the paper. And we still need to know the difference between clockwise and counterclockwise. Don't forget those. Those are going to come up a lot today. And they also usually come in 90-degree increments, as we talked about yesterday too. 90, 180, or 270. Really, 270 is just 90 in the other direction. All right, there was a kind of hard way, as I said, and I just showed you how to do that. And then there was also like a kind of easy way where I just rotated the paper. And that was super nice. All right, so this one's already been rotated all of the places. So this original triangle is the one here in, whoop, I tried to cover that up, in blue. So this is the original triangle, and it's been rotated 90 degrees that way, and 90 degrees that way, and 180 degrees. So I want to talk today about coordinates. So here's what I'm going to do. You're going to see a pattern in here real quick. Let's do one vertex at a time. So the original point A was, let's see, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So the original point A was at 4, 7. At the 90-degree rotations, 90 and 90, let's look at the coordinates of the new A. So this one is at -7, +4. And this 90-degree rotation down here, the purple one, is at +7, -4. Take a careful look at those coordinates. Look what happened. So the original A was 4, 7. The 90 degrees were -7, 4, and 7, -4. So when you rotate something 90 degrees, the two coordinates flip, and one of them becomes negative depending on which way you rotate it. I don't need you to memorize which, but just notice that that's what happens to your coordinates. They flip spots, and one of them becomes negative. It depends which way you rotate it. What about the 180-degree rotation? Original point A was 4, 7. The point A down here is at -4, -7. Again, notice what happened to the coordinates. In this case, they're the same spot, but they both became negative. Let's try it again with B. Let's see what happens to. The original B is at 1, 2, 3, 4, 1. 4, 1. Let's start with the two 90-degree rotations for it. B here is at -1, +4. And in this one, it's at +1, -4. So again, same thing. In a 90-degree rotation, the coordinates flip, and one of them will change signs. I shouldn't say become negative over here, because if it was already negative, it would become positive. So one of them will change signs, either from negative to positive or positive to negative, and the other will not in a 90-degree rotation. In a 180-degree rotation, the new B here is at -4 and -1. So in a 180-degree rotation, all that happens is both coordinates flip signs, but they don't change spots. So see, last one, just to kind of drive the point home. C is at 4, 5, 6, 7, 8, 9, 1. So in the two 90-degree rotations, what you're going to see is that flip and one of the two numbers become negative. It depends which way you go. So this one's at -1, 9. Switch, one of them change signs. And this one's at -9, -1. Oh, that's the 180. I'm sorry. This one's at 1, -9. And then the one. So again, switch positions, one switches signs. And then the 180 is at -9, -1. No changing of positions, but they both change signs. So I want to point that out. I wrote that out in like sentence form for you, right? So like in a 90-degree rotation, the X and Y coordinates will flip and one of them will change signs. So like you'll notice in these two, if you circle any two identical points, the X and the Y are reversed and one of them has a different sign, in this case, the 1. Or in the B's, the coordinates are flipped. One of the two has changed signs, in this case, the B. In a 180-degree rotation, both coordinates will change signs, and that's it. Like this point on the L is 1, 2, and on the 180-degree rotation of it, -1, -2. So both coordinates change signs in 180, but they don't reverse like they did in the 90. And I'll have this printed out for you. I'll show it again in the WeDo, but I'll have it printed out for you in class. All right, let's do one together here. So same thing. What happens to the coordinates of the vertices when the figure is rotated? So what I want to kind of do is look at point A, point B, and point C. If you'll write that down. And I wanted to look at the original, the 90 degrees, the other 90 degrees, and the 180 rotation. And I just kind of want to look at those like a chart and see what happens to each set of coordinates. All right, so I'll give you some time to get this kind of drawn and looked at and set up. And here we go. So A, the original point A is at 1, 1. This one's going to be hard to tell what happens because the ones are the same. Actually, let's just skip it. Let's save you some time. You won't be able to tell that the ones change places in the 90, so let's just skip it. Let's do B. B is at 3, 1 originally. When it is rotated 90 degrees this way to the blue, it is at -1, 3. So notice the 1 change signs and they reverse spots. When it's rotated 90 degrees the other way to the yellow, B is at 1, -3. Again, now the 3 change signs and they flip spots. And in the green triangle, the 180-degree rotation, it is at -3, -1. So in that case, they stay, but the signs change on both. And same thing for C. C is at 1, 5. Rotate it 90 degrees to the blue. C ends up at -5, 1. Change sign, reverse spots. 90 degrees to the yellow, C is at 5, -1. Again, change spots, the 1 reverse sign. 180-degree rotation to the green, C ends up at -1, -5. Same spots, but both change signs. I don't need you to like necessarily memorize all that. I just want you to be familiar kind of with what happened. Makes it easier to spot a rotation when you see one, and just gives you some familiarity with kind of the rules of the game. You know, you always, if you really had to find them, you could always just like rotate your paper and find the coordinates. Would be totally fine. I just want you to have some comfort with it and notice some patterns. All right, so also for your notes, if we want to write this in, I think we should. In a 90 or a 270-degree rotation, one coordinate will change signs. Again, it depends which way you go. And the two coordinates will reverse, right? So like 3, 5 becomes negative 5, 3, something like that. So in a 90 or a 270, one coordinate will change signs and the two coordinates will reverse. In a 180-degree rotation, both coordinates change signs. And that's it. So like 3, 5 becomes negative 3, negative 5. And that's how it works. So that's what happens to the coordinates in a rotation. Fun and neat. I hope you thought it was interesting. I hope you found it easy to follow. If you need to rewatch anything, please do. Otherwise, I will see you tomorrow.